So let's start with the 2016 question number 3. We did part A, I think. It's part B. If you do not have the question, I'll write it briefly. So we have a sequence of x1, x2 up to xn. Be a sequence of random variables such that this sequence follows a binomial distribution with the parameters number of trials n, probability of success lambda over n. Okay, so this n is greater than lambda and lambda is greater than 0, and this is a constant. We have to show that the sequence xn converges in distribution to a Poisson random variable with parameter lambda. Okay, so which means you have to show that xn goes in distribution to x, where xn is binomial and x is Poisson with parameter lambda. Okay, so this is a convergence in distribution. Right? That means you have to start with the CDF. Okay, when you have to show the convergence in distribution, you have to use the cumulative density function or capital Fx for the CDF. Now we know that xn is binomial. You have to show that the CDF of the binomial density, okay, will converge to the CDF of the Poisson distribution when n goes to infinity. Okay, so what do we have to show? We have to show that the CDF of the binomial random variable converges to the CDF of the Poisson when n goes to infinity. Okay. Now, when you know that xn is binomial, how do you write now in this exam? Again, the density functions were given as a supplementary table. Anyway, if xn is binomial, these are the parameters. Then we know that how to write the PMF, right? The PMF is n choose x. Probability of success is lambda over n to power x. Then probability of failure, that will be 1 minus lambda over n to n minus x. This is the PMF of the binomial density. Now remember, these are discrete, right? These are discrete distributions. And then we have to show that it goes to Poisson. Now, what is the, before we find the CDF of Poisson, you need the PMF of Poisson. Okay? The Poisson density, that will be, now you should see the difference. This is xn, this is a sequence. This is just one single random variable. Okay, a sequence converges to a single point. Okay? Xn converges to x. So this single point that follows the Poisson. So the PMF of Poisson is lambda to x. Lambda is the parameter. Lambda to x, x is the random variable, e to the negative lambda divided by x factorial. Okay, so x will be greater than or equal to 0. And here, what are the possible values of x? X will be 0, 1, 2 up to n. N is the number of trials. Okay. So the values that xn, this sequence, the binomial density, they can contain values from 0, 1, 2, 3 up to n. The Poisson densities, it should be greater than 0. It can go up to infinity, right? That's the Poisson density. Now, since we have to show it converges in distribution, you need the CDF. Let me add new. I had about 10 pages. Let me start from the beginning. That's my document. Still only 10. Okay, we are fine now. So let me write down from the beginning. Okay, so let's start with the CDF of the binomial density. So how do you find the CDF? So capital F, now xn. Okay, our random variable is x. You have to sum up. Now this is a discrete case, therefore you have to sum up your PMF. Yes, the PMF. Starting from the lower bound, okay, for the binomial, x will contain values 0, 1 up to n, right? So from x going from 0 up to any x. Okay, if you think it will be confusing with the same x, you can use y as the dummy variable and continue. But anyway, the random variable x will go from 0 up to any x. Okay, so when you have discrete, you have to take the summation. When it is continuous, you do the integration. When it is the discrete case, you have to take the summation. Okay, so this is the CDF of the binomial. You have to show that this goes in distribution. So you have to show that this goes in distribution to the CDF of the Poisson density. Okay, anyway, we'll see how we can proceed with this one and see whether we can end up with the PDF of the Poisson. Now, what will be the PDF of the Poisson? Fx. That will be again sum of e to the negative lambda x x factorial. Okay, it's going from 0 up to nx. So this is how you write the CDF of the Poisson. Okay, so let's start from the CDF of the binomial and see whether we can show that it converges to the CDF that you see in the right hand side when n goes to infinity. Okay, so take the limit n goes to infinity of this CDF. Okay, so we write okay, since we are taking the limit, okay, so you can omit this summation anyway. We are taking when you take the limit, okay, so n goes from 0 up to infinity. So let's write it like this. Okay, I'm going to use k here, otherwise it will be confusing to you. Okay, just a dummy variable rather than x using k. Okay, it doesn't matter if you use x here, so you won't get confused with the same x in two places. Okay, so rather than writing x, I used k. K is it's similar to the x. Okay, right. Now our goal is to take the limit of this whole expression. Okay, the whole limit when n goes to infinity. Now you can see there are several other let's say letters that which are not depending on n. So you can take them outside. Okay, so only n is actually what you have to pay attention, because that is the limit. Then we take the limit for n. Therefore, k and lambda, okay, they are like constants, so you can take them out from this limit. Okay, right. So let's do that step by step. First, I'm going to take this lambda to power k out. Okay, there's a division. So lambda to power k, I'm taking it out, and we have the limit. We have this is n, and now if you want, let's write the n choose k, the usual factorial notation. What is it? N factorial, k factorial, n minus k factorial. So this is n choose k. This whole n choose k, you can write it as the expansion. Okay, so I have a request. Thundering and raining. I will be discussing, uploading the video. Yes, I will be uploading the video, so don't worry about it. And in my place also, there is a possibility of thundering if the power failure happens and the Zoom meeting goes away. That means I will not be coming back. Okay. But anyway, we'll try our best to see how far we can go. Anyway, I will be uploading the video and the discussion. Okay. So we already took lambda to k out. So we have only 1 over n. Okay, I'm going to write to the power k like this. It's not going to change anything. And the rest 1 minus lambda over n minus k, it is there as it is. Now, if you look at this, the factorial term, again, k is independent of n. You can take this k also outside, right? So let's write it, lambda to k factorial outside. And we have the limit, n goes to infinity, n factorial, n minus k factorial, and then we have 1 over n k, and the rest is there. Right, now look at the CDF we want. What do you want? E to the negative lambda to x factorial. Now we are replacing x with k. So if you write the same thing replacing k, what should you have? E to the negative lambda to k factorial. Okay, so anyhow, our right hand side should converge to this quantity. Now, if you look at this limit, we already have lambda to k and k factorial. See this part, we already have it. See, okay, so that means we have to show that the rest is e to the negative lambda. If we can do that, if this limit goes to e to the negative lambda, then we are done, because we already have the rest of the answer. Okay, so let's see how we can find it. Right. Now I'm going to do a small trick. It's not actually a trick, a way of solving the factorials. Okay. Can you expand this factorial? N factorial. And at the bottom you have n minus k factorial. So how do you expand n factorial? That will be n times n minus 1 times n minus 2 all the way up to 1. Right. So that is the factorial. And if you expand n minus k, what will you have? N minus k, n minus k, you subtract 1 by 1, right? And it goes on like that. Okay. Now, if you look at the top and the bottom, you can cancel out the bottom from somewhere, if you expand this n factorial, in somewhere in between n and 1, you will have this term n minus k minus 1, and the rest, it will be there. This goes up to 1. And what is the term in front of this? That will be n minus k plus 1. Can you see that? When you expand n factorial, it goes like n minus 1, n minus 2, and then you can say n minus k plus 1, n minus k minus 1, and so on. It goes up to 1. At the bottom, you have starting from n minus k up to 1. So you can, cancel this whole thing out. And what will be the remaining? So I'll write this rest. What will be the remaining from the numerator? You'll have n times n minus 1 times n minus 2 up to n minus k plus 1. And then this n to the k, I'm going to write it there. And the rest, what do we have? Again, I'm going to write this n separately. You can do that, right? Minus k separately. It's the same thing. N minus k, I split it into the power n and minus k. Is it clear up to this point? Up to this line, is it clear? Okay. Now, if you cannot figure out this factorial cancellation, just write down few numbers. Okay, write down few numbers and check it. Say, for example, if you have 10 over 5, let's say 6 factorial, where your n is 10 and 6 is n minus k. Okay, so which means your k is 6. Now, if you expand this, how do you write it? First like this, and 5, 7, 6, 5, all the way up to 1. And at the bottom, you have 6 times, 5 times, 4 times, all the way up to 1. So this whole thing goes away. So you expand, you will be end up with 10 up to 7. So this is exactly that what you have in notations of n and k. Okay. Right. Now, in this question, there was a hint given for that that question. So you have to use this hint. Okay, so when you are taking the limit, why didn't you take the summation? You can, when you are taking the limit means you are taking the sum, right? You are taking starting from 1 to, how can I say that? Now you are doing and starting from 0, 1, 2, 3, all the way up to infinity, you take it. Okay, so you don't have to, worry about that. Okay, right. So you can just start with the limit. So the hint given was, here's the hint. This was given in the question. This is 1. Okay, so the limit of this whole expression is 1. So that means if you take this limit of this whole part, this this quantity, it goes to 1 when n goes to infinity. So you can replace this whole thing with 1 when n goes to infinity. So that part is solved. Okay, so that part is solved. Now what do you have? The rest will be n goes to infinity. 1 minus lambda over n to k, 1 minus lambda over n to n. Again, if you look at this first part, when n goes to infinity, you see that n is at the bottom. So this part also goes to, this whole thing goes to 0. So 1 minus 0, 1, 1 to the power negative k, you'll end up with 1. Okay, so therefore, this part also goes to 1. Therefore, you'll end up with simply lambda to k factorial limit 1 minus lambda over n to power n. And if you know about the limits of, now this is a very familiar limit, this is exactly e to the negative lambda. Okay, so this is e to the negative lambda. This is something we use usually in mathematics, a well-known identity. So limit n goes to infinity, 1 minus lambda over n to power n is the e to the power negative lambda. Okay, so therefore you end up with the factorial e to the negative lambda. And what is this? This is exactly the Poisson distribution. So this is exactly the Poisson distribution. Okay, so that's it. So you have xn Gaussian distribution to x. Now what you have to the thing that you have to understand in a question like this is you have to look at the starting point and the ending point, and somehow you have to make arrangements in between your proof or in between your limit. So your final answer, you have to rearrange the terms and take the final answer somehow, right? So when you do these things, you have to look back and look at the final answer and try to make the terms so that you can end up with this expression for the Poisson distribution. And then you have the limit, you have the hint given there, and you have to look at that limit, and also you have to be careful how to, how can you take this factorial stuff. Okay, so then you have to, look at it and see how to expand the factorials and what will happen, and then you'll end up with a way to use your hint. Okay, and if you do that, you can end up with the Poisson distribution, that is the limiting distribution of the binomial sequence. Okay, right. So that is how you do question number 3, part B. Right. Is this clear to all of you? And then I thought to do 2019. Let's do 2019 question number 3. Where you have the moment generating function, a question based on the moment generating function. Okay, so this is 2019 question number 3. So have been given that mxt is the moment generating function, that is the notation, you already know that, of a random variable x. You have to show that if st is the natural log of the moment generating function. If st is ln of mxt, you have to show that the first derivative of st, when t goes to 0 is the mean, or ex. And the next thing you have to show is the second derivative of st. If t is 0, that is the variance of x. Okay, so you have to show these two quantities. Okay, so what do you have to show? You have to show that d over dt st. What is st? St is ln mxt. Okay, so this x is any random variable. The density function is not specified. It doesn't matter. Okay, we are going to just use the properties of moment generating function in this case. Okay, right. So let's start with the first one. You have to show that the first derivative of st is the mean. So let's start with the definition and then proceed. We know that st is ln of mxt. So let's take d over dt st, and you have to set t equals 0. Now, when you have this t equals 0, you do this t equals 0 after you do the derivative. Okay, you don't substitute t equals 0 and now you can't do that. Okay, if t is 0, you can't take the derivative with respect to t. Okay, so you do the first derivative and the final answer you set t equal to 0. Okay, so let's find it. You have d over dt. What is st? St is ln of mx t. Okay, and when you take the first derivative of ln term, what do you get? When you take the first derivative of an ln of a function, what do you get? Say ln of fx. You have 1 over fx and then what? If it is just x, okay. So if you have if you want d over dt ln x, that will be 1 over x, right? But if you have d over dt ln of fx, what is the answer? You have 1 over fx and what? The chain rule, you have to take the d over dt of fx, right? So don't forget the chain rule. You have 1 over fx and then you have to go inside the function and take the derivative of what you have inside this function. So you have d over dt fx. This 1 over fx times d over dt fx. So you have to do the same thing here, okay? For 1 over x, that's fine because d over dx x is 1, right? But when you have a function of x, you take 1 over fx and then times the derivative of fx. That is the chain rule, right? So let's do the same thing here. Now our fx is like the mxt. So you have 1 over mxt, fine, and then you have to take the derivative of mxt, right? And then you set this t equal to 0. Now, what do you know about this this part? What do you know about this part? If you take the first derivative of the moment generating function and set t equal to 0, what do you get? That is why we call it the moment generating function. What do you get? First derivative of the moment generating function, set it equal to set t equal to 0, you get the mean. Yes, you get the first moment. So this part will give you ex. And what about mxt? What is mxt? mxt is, now you have t equals to 0. Okay, mxt is, how do you write the mxt? That is expected value of e to the tx. That is the definition. And you have ex at the top. Right? And when actually we have to write it as a single line, not like this. Let me correct it. So when t goes to 0, this part goes to ex, and when t goes to 0, what will happen to this one? The expected value of e to the tx. When t goes to 0, you have expected value of e to the 0. E to the 0 is 1. So you have expected value of 1. So what is E1? It is simply 1. So at the top you have EX, at the bottom you have E1. Right? So E1 is just 1. So you'll end up with EX. And that is what we have to show. Right? So the first one is done. Okay, is this clear? Any question? Anything unclear? Okay, so let's move on to the next one, the second derivative. Okay, now you take the second derivative of st, right? So let's use the answer of the first derivative. Okay, here's the answer of the first derivative. Let's use this one and take the derivative again. That will be the second derivative, right? Okay, so we take the second derivative. of mxt, sorry, st. Right, we want to take d over dt of the answer of the first derivative. What is it? Okay, I'm going to write d over dt mxt divided by mxt. Okay, and so this is the second derivative of st. Now let me write it in another way so you can take the derivative easily. Instead of d over dt mxt, I'm going to use the notation prime. Okay, so this is another way to write the first derivative, answer of the first derivative, mx prime t. This means the first derivative of mxt. Okay, I hope you know this notation, right? So if you have d over dx, give me a minute. Right. So you know that you can write it like this, right? Okay, so you write usually with the fx, we do that. This is fx first derivative, second derivative, and if you do the third derivative, you write it like this. Okay, you can do that with this one. So instead of d over dt mxt, I'm going to write m prime mxt prime. Okay, just to make the notation easy. Now let's take the derivative. Now what is this? This is the, you have the quotient. Okay, you have the numerator and the denominator, so you have to apply the quotient rule. Can you remember the quotient rule? What do? You get the one at the bottom, take the first derivative of the one at the top, minus one at the top times the first derivative of the one at the bottom, divide by the denominator square. Right? I hope you can remember the quotient rule. So let's write it down. I write the denominator, then the first derivative of the numerator becomes mx double prime minus the numerator, and the derivative of the denominator will be mxt, and at the bottom you have the square of the denominator, and then let's set t equal to 0. Okay. Right, like you did in the previous case. Now let's substitute t equal to 0. What is mxt? This is expected value of e to the tx. Okay, we already found that it is 1, right? This is 1. Anyway, I'll write it. And what is mx double prime t? That will be the second moment, which is ex square. Okay, so this will be the second moment. If you do mxt, the derivative twice, and set t equal to 0, you get the second moment, ex square, right? And what do you have here? You have, this is ex, this is also ex. So you have ex whole thing square. And at the bottom, what do you have? Again, expected value of e to the tx whole thing square. And when you say, okay, so we already set actually t equal to 0, and this becomes e to the 0. This becomes e to the 0, which is 1. E to the 1 is 1. So you end up with e1 times ex square minus ex whole thing squared divided by e1 square. And e1 is simply 1. So what do you get? Ex square minus ex whole thing square. And what is this? This is the computational formula for the variance. Okay, so that's what you have to show. Okay, so what are the things that you are tested in this question? Yes, what are the things that we are testing here? You should know the definitions of the moment generating function. its properties, what will happen to the derivatives when you set t equal to 0, the things that you end up with, that is the moments, first moment and the second moment. And then there are some calculus there, right? The derivatives, the quotient rules, the ln, chain rule, and simple things like that. Okay. Right. The main thing is whether you know how to deal with the moment generating function and how to simplify them when you do the derivatives. The whole idea is how you end up with the moments at each of these stages, right? How you end up with the moments, first moment and the second moment and their combinations. Okay. Is this clear to all of you? Any question with that one? Okay, so let's move on to the next part. The next part is, okay, there's another request about the same question, 2019 paper, question number 2. Okay, yeah, we'll try that also. So what is the second part of the same question? Part B. The number of earthquakes occurring per week in a certain region is a Poisson distribution. The Poisson distributed random variable with lambda 2. Okay, so what is our random variable? X is the number of earthquakes occurring per week. Now, you should remember that Poisson density, the Poisson random variables, they are always talking about rates per something, per time, per area. Can you remember? The number of typographical errors per page, number of seeds germinated per square feet. And then number of telephone calls received per 10 minutes. Okay, so it is the Poisson random variable. It is all about rates. So here it is the number of earthquakes occurring per week. Okay. So there they have the parameter lambda to be 2, and it is the Poisson distribution. So X is Poisson with parameter lambda equals 2. You have to derive the MGF of the above random variable X. You have to derive the moment generating function of the above random variable. And the second one, find the expected number of earthquakes and its variance using the results in part A. So you already know how to get the EX and YX. Okay, it's there. So using that results in part A, you have to find the mean and the variance of this random variable. Okay, first let's find the moment generating function. Okay. Since it is the Poisson distribution, we know the PMF. The PMF will be e to the negative lambda, lambda to x, x factorial, x going from 0, 1, 2 up to, it goes up to infinity. How do you find the moment generating function? That is the expected value of e to the tx. So you have to find it. Taking the expectation is whatever you have here times the ex. This is how you find the expectation. X will go from 0 up to infinity. So which is x going from 0 to infinity, e to the tx. What is our px? E to the negative lambda, lambda to x, x factorial. Right, so let's take the, now our summation is with respect to x. So you can take the entities which are not depending on x. The only entity which is not depending on x is e to the negative lambda. So let's take it outside. All the other terms contain x. So you have to keep them with the summation. Okay. Now this summation, you have to expand it and see what will happen. Let's see. Okay. X, when x going, what will happen when x is 0? When x is 0, what will happen? You have e to the 0, 0 factorial, lambda to 0. Okay. So you get, actually, if you think about ETX, I'll start with that. When x equals 0, what will happen to e to this one? This will be 1, right? Am I right? And if you think about now, okay, I think it's better to explain it like this. Let's take now this, since this is about this whole thing is about the expectation. If I write it like this, the expectation of x. Okay, now this is about the expectation of the random variable x. The expectation of x when x equals 0 is what? 0, right? So therefore, we can write this whole thing starting from x equals 1, right? So because it's not going to change the summation. Okay, the summation will not change if we write this whole thing starting from 1. If you want, you can keep the 0 and just put 0 in front. It's not going to change anything, just to make this expansion easy. I'll just write it like this. Okay. Now what will happen? So let's expand this, or let's substitute what will happen when x equals 1. So what is the value when x equals 1? You have e to the t, lambda to 1. So it is lambda, and at the bottom it is 1 factorial, 1. Okay. And when x is 2, what do you get? E to the 2, e to the 2 t. Let me check. I have rearranged the terms in a different way. I'll write it again. You can write this. So our substitution also becomes easy if I write it like this. Since you have x to the power x common for both, so I'm going to write it like this: e to the t lambda whole thing to power x. Okay. In that case, it is easy to do the substitution. Okay. Is it okay? E to the tx times lambda to x. I take the power, okay, to the power x outside. So I write e to the t times lambda whole thing to power x. Okay, it's the same thing, rearranging in a different way. So when I substitute the values, when x is 2, it becomes e to the t lambda square over 2 factorial. And then you have e to the t lambda to power 3 . Am I right? Am I right? I think I missed something. No, correct, right. Okay, so 3 factorial, and it goes on like this, right? And then I'm going to take this lambda e to the t outside, because you see lambda e to the power t in all the terms. Okay, so when you have e to the t lambda all the terms, so I'm going to take it outside. So from the first term, you'll end up with just 1. And then here, 1 term is gone. So you have lambda e to the t 2 factorial. 1 term is gone. So you have lambda e to the t square 3 factorial, and it goes on like this. Okay. Right. Now, what do you think? What can you say about this series? This now this is a infinite series. can you figure out the common factor here? What is this? This is the summation. Okay, we already used it. Okay, so yeah, I think I found some answer. Some of you have given the answer. When you have the summation, the infinite series. Okay, so this is actually e to the lambda e to the t. So that means e to the whatever. Now you can see this quantity, it goes as e to the power, right? Because if you do okay, this is e to the x, right? So the same thing happens here. So this whole series becomes e to the lambda e to the t. Therefore, you'll end up with e to the negative lambda e to the lambda e to the t. Now, let me check whether the hint was given in the question. Yes, as a hint at the end of the paper, this hint was given, so you can use it here. E to the x is sum of t going from 0 to infinity, xn, and factorial is there, right? So from that itself, you can get this answer. Okay, so if you want, use this hint straight away without expanding all these things, you can easily do that. Okay, so if you can figure out that this whole summation is e to the x, where x is lambda e to the t, that's what you have to figure out. Okay, yeah. Now you replace this infinite series with e to the lambda e to the t, and then you have e to the negative lambda outside. So what do you get? You get e to the lambda e to the t minus 1, right? E to the lambda e to the t minus 1. You can clearly see that if you expand this, you'll get combine the same base, negative lambda e to the t, you'll get e to the lambda times e to the t minus 1. Okay, and in our case, lambda is what? Lambda is 2. So what do you get? Your mxt becomes substitute lambda to 2, you get e to the 2 t minus 1. So that is the moment generating function. Okay, right. Now you found the moment generating function, the rest is easy. Okay? When you have the moment generating function, finding the mean and the variance, you can use the previous result easily, because you have the ln of e is very simple, right? Right. So let's use the answer in part A. What do we know? We know that ex is d over dt st, which is d over dt st is ln mxt, right? So if you take ln of this one, what do you get? Ln of e to the 2et minus 1. Well, ln and e, it's like they go away. Very simply, you get 2 times e to the t minus 1. So taking the derivative of this one, it's well, it's simple. So what do you get? You get 2 times 2 is a constant, with derivative with respect to t, et is simply et, negative 1 is 0. Set t equal to 0. What do you get? 2 times to the 0 is 1, so 2. So the mean is 2. What is the variance? Variance is the second derivative of st. So in our case, that will be the second derivative of this one, 2 e to the t minus 1. right? So that will be d over dt. You already have the first derivative of this quantity, which is 2 times et. So you take the derivative again of that, you'll end up with simply 2 et again, right? With respect to t is to 0. This is 2, right? Again, it is 2. And you can double check your answer, because with the Poisson distribution, you know, both mean and the variance, they are the lambda. The lambda is 2. So, well, you can verify your answer from that also. Okay. Right. I think the hard part is, you know, figuring out this moment generating function of the Poisson distribution, right? Well, but with the hint, I think you can get it done. Okay. Is this clear to all of you? Okay, let's go to another one. There was another request, 2019. Hold on. Question 2, part B2. Okay. Right. 2019. Question number 2, part B2. Okay. Right. If I mention about, I think I'm not sure whether we do part B. No. Anyway, this was the question. In part 1, you have to find the min and the max. Okay. Part 1 was about finding the min and the max. The PDF of min and the max, you know how to do that. The order statistics, when you know the PDF, you have to find the CDF. You can easily do that. Okay, for this distribution. Find the CDF, and you know how to derive the minimum and the maximum. The equations are there. Okay, so you compute the min and the max. In part 2, what you have to do is, if I give the answers for part 1, the minimum was this one. I suppose you can try this one and find it easily, right? How do you find the minimum? This is n times 1 minus fxy to power n minus 1 times fxy. From that, you can find the minimum. And the maximum is 6y5. How do you find the maximum? N times fxy minus y fxy. Okay, from that, fx is given. You can find capital Fx by integrating from 0 up to x. Then using this formula, you can find the min and the max. So these are the answers you will find from part 1. Okay. Now in this question, we have only a random sample of 2 observations. Okay, so if I write the order statistics, you have the minimum y1, you have the max y3 because the sample size is only 3. And what is the middle one? Middle one is the median. Median is y2. Okay, always the ordered data, the middle number is the median. Okay, so part B 2 is to compute the probability that the minimum, which is y1, exceeds the median of x. Compute the probability that the minimum exceeds the median of x. Okay, so what does that mean? The minimum is y1. What is the median? Median is y2. Okay, now the first thing, you have to find the median of x. Okay, then there should be a number, right? If you want to integrate. Okay, so you have to find the median of x. Since the distribution is given, you can find it. Okay, how do you find the median? Okay, let's say t is the median. Let's say let t be just a letter. Okay, you can use any letter here. If you want, you can use m. Let t be the median of this sample. Okay, let t be the median of this sample. Now we are going to find the median. How do you find the median? What do you know? What is the property about the median? Median is the midpoint. You have 50% of data to the left, 50% of data to the right, or 0.5 probability, 0.5 probability, because it's the midpoint. Total probability is 1. Exactly at the median, it divides the whole data set into two parts, first half and the second half. Therefore, if you integrate starting from the left boundary up to the median, what is the probability? It should be 50%. Okay, so that means if you integrate your PDF starting from the lower bound up to the median, what is the answer? The answer should be 50% or 0.5. Okay, well, we know fx, so let's find it and solve t. That's all you have to do. So integrate from 0 to t. What is our fx? It is 2x. The answer should be 1/2, right? Okay, so if you take the integration of 2x, that will be 2x to the power 2 divided by 2. Evaluate from 0 up to t, the answer should be 1/2. So you get, when you evaluate x at 0, it is 0. When at t, x is t. So you have t square minus 0. So I'm not going to write the 0. So this t square should be what? 1/2. Therefore, what is t? T is plus or minus square root of 1/2. Now, what do you know about x? Now, t is what? T is the median of this random sample. But we know that the support of x is from where to where? Support of x is from 0 to 1. Okay, x is from 0 to 1. Therefore, you don't have the negative sign. You can drop the negative. Therefore, t becomes simply the positive square root of 1/2. Okay, t becomes positive of the square root of 1/2. The negative can be dropped because our sample x, the variable, random variable x, the support is from 0 to 1. It contains only values in between 0 and 1. All the others, they are not valid. So the negative square root of 1/2 can be dropped. Therefore, our median is square root of 1/2. Now, what do we have to find? The probability that the minimum exceeds the median. Probability. What is the minimum? y1 exceeds the median. What is the median? 1/square root of 2. So find it. You integrate. Now here's the lower bound, greater than 1/square root of 2, up to the upper bound is 1, right? It's from x from 0 to 1. So greater than 1/square root of 2. So evaluate from 1/square root 2 up to 1. Now remember, you are doing y1, okay? Not x. What is y1? Y1 is this one. 3 times this. You can write this as 6y. So I'm writing it as 6y 1 minus y square. Okay. See, 3 times 2, 6. 6 times y times 1 minus y square to the power 2. So that t, remember this is y. Okay. So we are doing the probability of the minimum, not there's no x anymore. Okay, so you have to take the distribution of y1 where you already calculated in part 1. Take it and do the integration from lower bound up to 1. Okay, so I'll leave it for you. Do this integration and the answer should be 1/8. Check it. Okay. And there's another way to do this. See, here's the other way. Or you can do it like this. You have to find that y1 is greater than 1/√2. Okay. So this is same as the probability y less 1 minus probability of y less than √2, right? Greater than or less than, you do 1 minus. And what is this? This is the CDF of the minimum. Okay, so and we know the CDF of the minimum. If you use the CDF of the minimum right, from the equation, you already know it. That will be, so you can write y minus the CDF of the minimum is y to power 3, right? So this will be how you because try this one. Okay, 1 minus 1 minus, there are things that will cancel out and you'll end up with this one. Okay, and here your y value you have to evaluate at median, right? What is the median? T, this one. Okay, so if you do that, you'll end up with 1 minus t squared to power 3. Again, t is square root of 1/2, and you'll see that it is going to be 1/8. Okay, I will get the same answer. Try both of them. Okay, to do this one, you need the CDF of the minimum. You know the equation, you can find it easily, and substitute the median. You found the median 1/√2. Substitute it in the CDF, and then you can get the probability. Okay. Right. So maybe I did it a little bit quickly, but okay, look at it leisurely and try to understand it. Okay. Now, when you have a question like this, what is the probability that the minimum exceeds the median? So you should know how to find the median. Okay, the property of the median, which is the midpoint. If you do the integration, it is 1/2 or 50%. This information you should know. Okay, this is you learn these things in first year. So this information you have to, that should pop up in your mind, and from that you understand that you can calculate the value of t. You find it, and you have to drop unwanted values depending on the support of x. And after you find the median, it is all about the minimum x is in the medium. So you don't have x anymore, it is all about y. So you have to use the distribution of y1 or the minimum, not x. Okay, so you have to use the distribution of the minimum and then do the integration to find the probability. Okay, right. So that's 19 to be part 2. And there was another request, question number 1, part D. Did we do it? I think we did question number 1 last time in a previous discussion. Didn't we do 2019 question number 1? I think we did it. Let me check what else. Okay, so there's another request, a 2017 question 3 part D. Okay, in 2017 question number 3 part A and B, you don't have to worry. The chi-square student T, now these things I will not be tested. Okay, so you don't have to worry about the describing the distributions and things, the chi-square student T and F distribution. In part D, okay, I think I got another email about this question. They should be independent. Okay, it was printed as dependent random variables. It was corrected as independent. I think then you know how to do it. Okay, so do you want to? We have x1 up to x25 and y1 up to y25. They are IID. They should be independent. Okay, and x follows normal 125 and y follows normal 260. Okay, and they are independent. Now you know how to do it. Okay, and you have to find the probability x bar greater than y bar 25. I think we did a similar one last time. So you do it like this. Okay, and since these are the means, you know the means will follow with the central limit theorem. It will be this one, right? So you can figure out what will happen with x bar minus y bar. The means you will subtract, and the variances you can add and dividing by the sample sizes. Okay, and you can find it. I think we did a similar one like this. I think you had the problem because they were mentioned as dependent in this question. It should be independent. Okay, then you know how to do it. Okay. Okay. Now shall we move on to tutorial 4? Okay. Okay, can you see the tutorial number 4 now? Is it visible? Tutorial number 4? Okay. So the first question, suppose that the random sample x1, x2 of size 2 is drawn from a population that has an exponential distribution with mean 10. Let x1 be the sample minimum and x2 be the sample maximum. Well, obviously, if you have only two values, x1 is the min and x2 is the max. You have to find the conditional probability x1 less than 5 given x2 less than 10. Okay, what is x1? What is this actually? This is actually y1. This is yn, or the min and the max. Right, so you have to find the probability that the minimum less than 5 given that the maximum is less than 10. Okay, so when you have questions like this, try to understand the general meaning of it. Okay, the usual meaning of it. This is a conditional probability, and you know how to find a conditional probability. What is probability of A given B? It is their intersection divided by the given one. Okay, so you know that the values are given: x less than 5, x less than 10. If you take the interaction, what will happen? Okay, we'll see how to figure this out. And then in addition to that, you have the minimum and the maximum, not just x. Okay, it is x1 and x2, which are the order statistics, minimum and the maximum, which means first you have to find the minimum, the density of the minimum, the density of the maximum, and then we'll see how to find the conditioning. Okay, right. So what do we know? We know that x is exponential. Okay, x is exponential with mean 10. Okay, if you know mean is 10, If mean is 10, what is the parameter? If you say lambda, what is the parameter? Parameter is, because mean is 1 over lambda. Okay, so lambda will be 1 over 10. Okay, so our distribution x is exponential with parameter 1 over 10. And x1 and x2 both. Okay, they are exponential with mean 10, which means the parameter 1 over 10. Okay, we want to find the probability x within parenthesis 1, not just x1, parenthesis 1, which is the minimum, is less than 5, given that the maximum was less than 10. Okay, now let's first apply the conditioning. Okay, so what is the meaning of the conditional probability? Probability of A and B, their intersection. So let's write x1 less than 5 and x2 less than 10 at the top, and at the bottom you have the given one. What is the given one? Probability x2 less than 10. Okay, now let's look at this AND part, this intersection. Okay, let's draw the number line. Okay, it goes from, okay, we don't know where it starts, and it will go over to the left and to the right. So you have 0 somewhere, just some numbers, okay, something like this. Now what do you know? X1 less than 5. So where's the less than 5 area? Since this is exponential, it cannot be. Yeah, so the lower bound is 0. Exponential density, x is greater than or equal to 0. Can go up to infinity, but lower bound is 0. So when you say x less than 5, here's the area, right? Less than 5. And then you have x less than 2. So what is the area for less than 2? Sorry, less than 10. Here's the area for less than 10. And what is the intersection? Intersection is where you see both colors. So where's the intersection? Here's the intersection. So the probability both x1 less than 5 and x2 less than 10, that area is simply x less than 5. Can you understand that? This is the overlapping area. Intersection is the overlapping area. The probability x1 less than 5, okay, and x2 less than 10. Anyway, this x1 and x2 are the two numbers that you have in the sample, right? So if x2 is less than 5, here's the area. If it is less than 10, you have the pink area. Where they overlap, that is the intersection. That is less than 5 area. Therefore, this conditional probability simplifies to probability x1 less than 5 divided by x2 less than 10. Now you can see that it is not that hard, right? Just finding this is what actually the CDF of minimum at 5. This is the CDF of the maximum at 10. So if you can find the CDF of the minimum, and if you can find the CDF of the maximum, that's all you need. You are done. Evaluate them at 5 and 10, divide, you'll get the answer. Okay, is it clear up to this point? This conditional probability? Right? Okay, so let's proceed with the finding the CDF of the minimum and the max. Now what do we need? First we need the PMF, right? The PMF of x, when it is the exponential density, that is when x is exponential with parameter, let's say theta, that will be, what is the distribution? How do you write the distribution? Theta e to the negative theta x. Okay, so this is the PDF of the exponential density, and this will be given to you, right? So you don't have to memorize it. So in our case, we have our theta or our, okay, whatever the parameter is 1 over 10. So I'm going to write fx as 1 over 10 e to the negative 1 over 10 times x. And then you have to find the CDF. How do you find the CDF? Integrate fx from 0 up to x. And if you do that, you will find it is 1 minus e to the negative 1 over 10 x. This is the CDF of the exponential density. You can derive it and find it. Okay, try it. Okay, very easily you can get this answer. Now using these two quantities, you can find the min and the max. Okay, so for the max, in our case, Fyn, our n is 2, therefore you can write just y2. What is it? Okay, this comes from the formula, right? Now in this question, now this is a tutorial, but in examination, maybe there will be a part for you to derive the CDF. Okay, so you know these equations will be there for you, so you know how to get it. Right. So here's the right. Here's the CDF of the max to the power n. N is 2. That's it. And what is the minimum? For minimum, the CDF of the minimum is 1 minus 1 minus. These equations are, we already did these things, right? So you have them in the notes. Get them and apply it. So you have 1 minus. When you have 1 minus fx, 1 and 1 cancels out. You'll end up with simply e to the negative y over 10. This to the power of n. N is 2. Okay. Then now let's find the probability x1 less than 5. As I mentioned, this is simply the minimum evaluated at 5. So here's the minimum, 1 minus e to the negative y. You have to evaluate at 5. So you have 5 over 10 to the power 2. So very simple. You get 1 minus e to the negative 1 over 2 square. And this will become 1 minus e to the negative 1. Okay, that is the probability minimum less than 5. We leave it there and then let's find the probability, the maximum less than 10. Again, that will be capital F at yn, or you can say 2. In our case, it is only 2, n is 2. So that becomes, what is our max? 1 minus e to the negative y over 10. Our y is 10, so you can write 10 over 10 to power 2. See this y? This y is there. We evaluate y at 10, so this becomes 1 minus e to the negative 1 square. Okay, so what is the answer? Probability x1 less than 5 given x2 less than 10 is probability x1 less than 5, x2 less than 10, and we found that at the top we have 1 minus e to the negative 1. At the bottom we have 1 minus e to the negative 1 to power 2. So 1 will cancel out. What is the answer? 1 over 1 minus e to the negative 1. And if you use a calculator, you can find this number. If you leave it like this, that's also acceptable. Okay. So don't panic when you see conditional probability. Okay. Don't panic when you see conditional probability. You can start with the definition and figure out the intersection, and you'll see that it is just another probability. Okay. Any question from this one? Okay, so let's move on to question number 2. Another order statistics one. Suppose x1, x2, x3, only the sample size is 3. Random sample drawn from a continuous distribution with density function is given there. Let the resulting order statistics x1, x2, x3. So you have the minimum, median, and the maximum. x1 is the minimum, x2 is the median, and x3 is the maximum. Evaluate the mean and the variance of the sample minimum. Okay, so you have to find the mean and the variance of the minimum. That means you have to find the density of the minimum first. Okay, so let's start with that one. We know that fx is 2x. I think this is the one in the exam paper, right? Anyway, yeah, we already did it actually. Yeah. Okay, so we have a question. Can we use the function for max and min directly without proof? Now, this is a tutorial. Okay, for tutorials, it's okay. In examinations, I usually give you to derive it in the previous part. So your part A will be to derive minimum and the maximum. So you know you have the equations derived there. Then you use it to answer the next parts. Okay, so usually I ask you to derive in examinations or at least to show it. Usually you have to derive it, but in exams I ask you to derive it, so you don't have to worry. There will be, I'm not asking you to memorize it and use it in the exam. It's not practical. Okay, so most probably in exam, if you have to use min and max their PDFs, there will be a question as a part at the beginning to derive it. So know how to derive it. Okay, then use that answer in next parts. Okay. So here's and I think we did this in the exam paper anyway. I'll write here's the minimum. Yeah, this is the one we did actually. So if you want to find the mean of this one, how do you find it? Expectation of y. Right? So y times fy, what is fy1? 6y1 minus y square. Evaluate from 0 to 1. X is from 0 to 1. So obviously, when you order them, they are also from 0 to 1. So do this integration, you can find the answer. Okay. In order to find the variance, first find the second moment, ey square. You integrate y square 6y1 minus y square. Now this you have to find, okay, and we did it in the exam, the discussion, the exam paper. So you have it. If you do the second moment, you can find some number here. Then your variance will be this one, right? So that will be, so you can find the answer. Okay. Right. So try that one. Then you have to evaluate the mean and the variance of the maximum. Okay. So again, first find the PDF of the max. So if you do that, you'll end up with this one. We derived that also in the discussion. Then you have to find the expectation of that, y times this one. You can find it. And if you want to find the variance, again, find the second derivative, the second moment, y square. And the variance will be this. Okay, so you can find it. That's not hard. Right, we move on to, okay, question number 3. It's the same. Okay. It's again the same thing. You have the same function in question 2. You already have the minimum and the maximum. Evaluate the covariance between x1 and x3. Well, you know how to do that, right? The covariance between x1, let's say y1 and y3. Okay. So that will be y1, y3. Right. And the correlation, you have to divide covariance by the standard deviation. You know the equation to this one. Okay, you can easily find it. So I'm not going to do, these are simple calculations. Okay. Okay, so let's move on to question number 4. A customer service window has waiting time distributed exponentially with lambda 5. Okay. So the customer service has waiting times distributed exponentially. So what is our random variable? Waiting time. So that is exponentially distributed with lambda 5. So that's given. If a sample of 5 customers are selected, so n is 5, calculate the expected maximum waiting time. So again, what do you have to do? First, find the PDF of the max. You can find it, right? You can find the PDF of max. You have to use n to be 5. Okay, you know the equation, PDF of the max, right? Right. So you have this equation. So find the PDF of the max with n equals 5. With lambda 5, you can find the PDF. And then you have to find the expected maximum, that is E of y. So this is yn, right? E of yn. Just find the, use your PDF, integrate y times the PDF of max. Okay. So from that you can find the, okay, so this is yeah, exponential distribution 0 up to infinity. So you can find the expectation. Find the probability that the maximum waiting time is less than 8 minutes. So that is the probability yn is less than 8. So that will be, you have to integrate 0 to 8 if yn. That's it. Okay. I'll give you the answers. Check whether you can get this. If you find the PDF of the max, it will be, let me check, 5 times 1 minus e to the negative 5y. I don't have enough space. 4 times 5 e to the negative 5y. This is the PDF of the max. Okay, so use it here. And if you do that, oh, I don't have the final answer anyway. You'll end up with 25 times, evaluate from 0 up to infinity y times e to the negative 5y. Okay, you can solve this one. And if you do the probability, you will do 0 up to 8, 25 e to the negative 5y minus e to the negative 5y. Okay, and you'll end up with 1 minus e to the negative 40 to power 5. Let's see whether you can get this answer. Okay, so the only hard thing is deriving the PDF. After that, you know how to find the mean, how to do the probabilities. That's simple. Okay. Right. So let's move on to the next one. Okay, so this is the central limit theorem. I think it's better to discuss this one. You have a random sample x1 up to x10 and another one y1 up to y10. Two independent random samples from two normal distributions. X following normal with mean and variance given there. Y following normal with mean and variance given there. Okay. What do you have to find? You have to find the probability x bar greater than y bar. So these are the means. Okay, so you have to do the sample means. And what do you know about the sample means? From the central limit theorem, what do you know? The sampling distribution of sample mean. Let's write it. The sampling distribution of sample mean. What do you know? Expectation of x bar is same as the population mean, and the variance of x bar is the population variance divided by the sample size. The sample sizes are 10 and 10 for both cases. Right. Now let's try to find this probability. Keeping these things in mind, we want to find the probability x bar greater than y bar. Okay, so that means the probability x bar minus y bar greater than 0. Okay. Now let's say our new random variable w is x bar minus y bar, the difference of two independent normal distributions. So what will be, you know, it is going to be normal. Mean will be the difference of the means. So here's, so I'll write 1 minus 1. Okay, you get the difference of the means, and the variance will be so for x, let's write ex bar is 1 E y bar is also 1. What is the variance of x bar? That will be 12 over 10, and variance of y bar will be 15 over 10, right? So therefore, when you take the difference of x bar and y bar, you take the, when you have the variance, whether it is subtraction or addition, it's all, when it comes to the variance, you add the variances all the time. So you have to add the variances of x bar and y bar. That will be 12 over 10 plus 15 over 10. Okay, although it is the x bar minus y bar, when you find the variance of x bar minus y bar, you always add. Okay, if it is plus, still you add. If it is negative, still you add. Don't do minus, okay, with the variance, because this minus will come with the covariance. When it is independent, the covariance term is 0, so you don't have to worry. So what is the density of W, x bar minus y bar? This will be normal. Actually, this is the approximately normal, with mean will be 0. And what is the variance? 27 over 10, right? So the probability W greater than 0, right? And let's standardize. W minus its mean is 0 divided by the variance. So you do the same, 0 minus 0 divided by 27 over 10. And what is this? This is Z greater than, this is 0. Okay. And what is the probability? What is the probability? The standard normal density greater than 0. You don't have to read the table. You know it. The standard normal density is symmetric about the mean 0. So what is the probability set greater than 0? 0.5. Yes, exactly. So we are done. Okay. So if you have some other number here, you'll get a certain Z score, read the Z table and get this probability. Okay. The tables will be provided to you. So read the table and get this probability. Is it clear? This one? Here you have to be careful. Okay, x bar, y bar. You should know this is the sampling distribution of sample mean. So the variance is sigma over n, sigma square over n. Okay, so you have to use that when you do x bar, y bar. Any question? Okay, right. Let's move on to the last question in the tutorial. Okay, so this one, again, you have the sampling distribution of sample mean. So let's do this one. And you will see similar questions in exams also. So this will be a good practice, okay, for you. Exam scores of a placement test is known to be normally distributed with mean 78 and standard deviation 3. So what is our random variable? Exam scores. Let's say that is X. X is normally distributed with mean 78 and standard deviation, or the variance, standard deviation 3. Suppose the candidate is randomly selected from a sample of 100. What is the probability that he has score greater than 90? He or she has score greater than 90. Now look at this. What is the probability that the score is greater than 90? So what is the score? Random variable X. X greater than 90. What is the distribution of X? Normal with mean 78 and the standard deviation 3. So this is simple, calculation with normal distribution. So let's standardize it. Normally distributed with mean 78, 90 will be somewhere here greater than 90. This is what we want. When you standardize, you get the standard normal distribution, symmetric about mean. You have to find the Z score for 90. So find the Z score, 90 minus 78 divided by the standard deviation 3. Can you find this value for me? 90 minus 78 divided by 3. So this is same as probability Z score. What is it? Let's do the calculation. 90 minus 78. You don't need a calculator to do that. Yes, it is 4, right? 90 minus 78, 12 divided by 3, 4. So Z score is 4. This is what you need. And what do you know about this one? You know the normal distribution, the table. This is approximately, the very at the very end of the tail is 4. So this is actually approximately 0%. Right? So probability is approximately 0%. You can try reading the table. You will get 0.0000 something. Okay. So you can simply write 0%. Right? Greater than 4. Okay. Now the next question is, what is the probability that the average score is greater than 80? Not the score, but the average score. So can you see the difference between part A and part B? Part A is the score. You select a student randomly and the probability that the score is greater than 90. But in part B, it is the average score. So what is that? Probability that X bar is greater than 80. See, it is different. X greater than 90 and X bar greater than 80. X and X bar, those are two different things. If you know X is normal with mean 78 and sigma 3, what is X bar? X bar is normal with the sampling distribution of sample mean. Mean is same as the population mean. And what is the sigma? It should be sigma over square root of n, or sigma square over n. In standard deviation, it is sigma over square root of n. So that will be 3 divided by square root of 100, which is 3 over 10. Now it is not 3, but it is 3 over 10. Okay. Now I'll do the same thing again, but with the different standard deviation. So here's our exam. 78, here's 80. You need greater than 80. Standardize. Find the Z score for 80 minus 78 divided by 3 over 10. Okay. Is it, hold on, no, it is wrong. Sigma over square, oh yeah, sigma is 3, right? Yeah, sigma is 3. So it is 3, yeah, it's correct, 3 over 10. So what do you have? Can you find this number? 30 minus 78 divided by 3 over 10. 6.67. Okay, another huge number somewhere over here. Obviously, that probability is also 0%. Okay. Can you explain tutorial 3, question 5? Question 5, part B. Okay. Tutorial 3. I don't have that tutorial 3 with me now. Which one is a part B not discussed in the video? Let me check it. So in the online discussion also, isn't it conduct? Anyway, let's see. Tutorial 3, question 5, part B. I'll check it. I don't have it with me now, the tutorial, but I'll check it and let you know. Okay. Uh, 2013, I don't have that paper. Do you refer up to that far? 2013, I was not here even. I don't know who taught it. Maybe Professor Vijay Kon. Very, very hard question, hopefully. 2013, I'm sorry, I don't have the paper with me even. Sorry about that. If you can send me a screenshot or something, I'll check it, okay? I started teaching this since 2015. Okay, 15, 16, 17, 18, 19. That's it. Other papers, I'm sorry, I don't have them with me right now. Okay, well, that's all I thought to do today. I think from the questions that we did, the questions that you have problems will be very similar to the things we discussed. So try to apply those methods. Okay, try to apply those methods, and you'll be able to figure them out. Maybe slight changes, but with the knowledge you have, you will be able to tackle them, right? Since we have done several examples in 3 discussions and the tutorial, I think we have covered almost all the possible questions. Okay. I want to do a small poll with you. Yeah, this is just to get an idea about how this discussion was helpful or not, because we couldn't do any evaluation for the course. Okay, this is just for my knowledge to my my evaluations. I'm going to distribute a poll now. Try to answer it. This is anonymous. You don't have to worry. Your registration numbers, names, nothing will appear. Just anonymous, like a Google survey. Okay. So I'm going to launch a poll. Please, there are only 2 questions. Please answer it. Okay. Okay, I guess I can end the poll. Okay, thank you very much. Out of 90, 81. So where are the others? Just logged in and sleeping? I don't know. Okay, anyway. So I got one of you have shared the tutorial number 3. Question number 5 is about the Poisson and Poisson theta, Poisson lambda, the conditional density. Okay, that question, yes, it has a lengthy calculation actually. And this one goes with the factorials rearranging like the one I did at the very beginning of the class, because with the binomial density and with the summation, you can rearrange the factorials and come up with the, at the end, it will become Poisson. Okay, I'll try to share the answers with you, okay?